Alright, this is 2018 complex numbers. So Z1, Z2 and Z3, you've got to plot them all on the Argand diagram. So we had to find Z3 first. So Z3 is found by Z1 take Z2. So you sub in, right? You're going to sub in for Z1 and Z2. Notice my brackets. Because when I get rid of the brackets, so minus 2 plus 3i is fine. Nothing is happening there. However, we want to minus a negative 3, which means it changes to a positive 3. We want to take away a negative 2i, so it changes to plus 2i. And then it's just reals together and imaginaries together, and Z3 we get 1 plus 5i. So to plot them, Z1 is minus 2 plus 3i. So you go across to minus 2 on the real axis, up to 3i. For Z2, it's minus 3 and minus 2i. So we go down and just plot Z2 there. Z3 was the one we just found, and we get 1 plus 5i. So that's Z3 there. Alright, for part B. So it says, investigate if the modulus of Z3 equals the modulus of Z1 plus the modulus of Z2. Now just a brief recap. Modulus, you know what you're actually finding when we find the modulus would be the distance from the origin to the point. So if we found the modulus of Z2, we would be finding the length of this line here. So how do I find the modulus? So I'm going to first find the modulus of Z3. So we have to have our formula here. We have a square root of a squared plus b squared, a being the number and b being the imaginary part there, the 5. So for Z3, the modulus is the square root of a squared, which is 1 squared, plus b, which is 5 squared, square root of 25, and we get the square root of 26. So that's this guy here, square root of 26. Now we need to check, does root 26 equals the modulus of Z1 plus the modulus of Z2? Let's find the modulus of Z1. So I filled it in there. Again, we're going to do the square root of the real part, and then your 3 squared minus 2 squared is 4, and plus 9, because 3 squared is 9, which gives us root 13. Z2, we sub in there, minus 3, minus 2i, so these were got from part A, the start of the question. A in this case is minus 3, and b is minus 2. So you square them, you get positive numbers, and you get 9 plus 4, which is root 13. So I'm just going to fill that up here, root 13 and root 13. Now, does root 26 equals root 13 plus root 13? Well, if you're unsure of your surd rules, some people might say that that equals root 26, but you would be wrong. It actually just equals 2 root 13. So it is not equal. It says investigate if they are equal. Conclusion, no. Not equal. Alright, for part C, let me move this up. For part C here, to find Z4, you have to divide Z1 by Z2. So if you want to pause this video during it, that's fine if I'm going a bit fast. So let's sub in. To find Z4, I have to do Z1 over Z2. So I subbed in there. Now, to divide complex numbers, I'll write this down. To divide complex numbers, you multiply the top and bottom by the conjugate of the bottom. Alright, so we need to find the conjugate of the bottom first. So minus 3 minus 2i is on the bottom. To find the conjugate, all you do is change the sign of the imaginary part. So the conjugate is minus 3 plus 2i. So you've got to multiply minus 2 plus 3i by minus 3 plus 2i. And then the bottoms together as well. So top by top, bottom by bottom. So again, to divide complex numbers, you need to multiply top and bottom by the conjugate of the bottom. So I did it separately here. I multiplied the tops here and multiplied them out. So I broke up my brackets, minus 2 by the second bracket and plus 3i by the second bracket. I worked that out. Remember, if you get I squared, you have to replace it with minus 1. So imaginaries together and real numbers together. So I got minus 13i here. And I subbed in I squared. I got minus 1 there. I end up with just minus 13i. So that's the top of the fraction. Okay, that's the two of them multiplied together. Then I had to go do the bottom. Now I did the bottom a different method, just depending on which method you did. My last video froze, so I had to do it again. So minus 3 by minus 3 is 9. Minus 3 by 2i is minus 6i. Then you do the next term, minus 2 by minus 3. And minus 2 by plus 2i is your minus 4i squared. Again, remember to change your I squared to minus 1. And you get 9 plus 4, which is 13. So that's the bottom. We got 13i, minus 13i on top, and 13 on the bottom. So when we put them back together, 13 goes into 13 once, 13 goes into minus 13 minus 1 times. Your answer is just minus I. So I'll leave that there for you to pause. And hopefully that makes sense.